Hello, everyone. A very cheerful morning to one and all. Hope you are at your best in this pandemic. I'm Srishti Vadhera and I will be your host for the session. Elevating the level of a hackathon that has a legacy of successful triumphs, we feel proud and honored to be the flag bearers of HackCBS 3.0 this year by hosting it in a digitalized way. To make the most out of this time and to help channelize the talent and energy of our beloved developer community, we are organizing a bunch of workshops and qualitative speaker sessions at HackCBS 3.0 this year. For more details about these sessions, don't forget to check out our website, hackcbs.tech. We hope to make these sessions as much as knowledgeable and insightful for you all so that you are geared up to build your hack by collaboration and contribution. I hope we are able to fulfill our motive and you guys are going well in the hackathon. Thus, let's get started with our today's session. Talking about today's first session, we have Jason with us. So,
Hello
hi
there.
Jason.
Nice to be here today. Thank you for inviting me.
So, Jason is Senior Developer Advocate for TensorFlow.js at Google. He's working with Google for more than 9 years. He's positioned within the TensorFlow and RMI Research plus Machine Intelligence Engineering Group led by Jeff Dean at Google, helping to spread the love for machine learning globally using web technologies across the stack. In today's session, he'll be covering how you guys can win a hackathon using JavaScript. He'll also walk through some of his learnings as to how he creates prototypes for Google these days. He'll be telling how you can get inspired by machine learning in the browser with several new examples the community has made and discover 7 easy to use machine learning models that are available for free using TensorFlow.js to help bring your creative ideas to life faster. And yes, you have heard of that Google Pixel 4a. Stay tuned till the end of this session. He'll also tell you how you can win that Google Pixel just by using TensorFlow in your projects at HackCBS. We welcome you, Jason, and look forward to your talk. The virtual stage is all yours.
Cool. Thank you very much. I'm going to go ahead and share my screen. 1 second here. Jolly good. Hopefully you can all
Yeah,
see my
sure.
screen now. It seems to be flashing. Is it flashing on your side or is it just on my side? Does it look okay? It's flashing. That's weird. Let me try sharing it again. 1 second. Okay, that's better. There we go. Jolly good. Hi everyone. So I'm Jason Mays, developer advocate for TensorFlow.js, and of course today I'm here to talk to you about how to win hackathons with JavaScript, which is my favorite language, of course. So let's get started. Now, some of you always ask me what my background is and why I'm here talking today, and essentially this slide summarizes my career history to date. I started off in the world of computer science at university. I then went on to be a web engineer on the back end, and then progressed into full stack web engineering. And it's at this point, I managed to be able to get to a point where I could make pretty much anything I wanted if I so desired, which led me to a different role at Google as a creative engineer or creative technologist, where I had to make new things for our clients using emerging technologies. And you can see some of the things I created on this slide, such as smart mirrors and computer vision-based search and all this kind of stuff. And then I finally got to do my dream role essentially as developer advocate, combining my love for JavaScript and my love for machine learning in one position. And that's what I'm here to talk to you today about. But there's one thing you take away from this slide is that I spent 16 years of my life using JavaScript, and it's actually changed quite a bit in that time. So if you've not used it in a while, you're in for a real treat. So let's get started with that. So when we are working for hackathons, we need to prototype faster than ever before. You need to go from idea to working code in a matter of days. Now, when I've been doing this in my previous roles at Google, in my creative engineering role, I also had to work in days and weeks to get these ideas into working prototypes to show to our clients. And I wanted to go through a few of the questions that I asked myself in order to get the best chance of making that happen. Now, the first thing I would look at is what's on my mind regularly. These are things you can all prepare before you actually start the hackathon. Now, chances are, if you're looking into something that you're already interested in, you'll be more motivated when you're hacking on it at the event. The other thing to think about is what problems in those areas actually exist. Now, many of the prototypes that I've created start with a problem that I faced in the real world, and that can be a good source of inspiration if you're not sure what you want to make. Also, What's new in the tech stacks that you're considering? Sometimes previously impossible things become possible due to advances in various technologies. And of course, the fourth point is who else is interested? It's really good to try and find and connect with folk who you maybe don't know before the hackathon, so you can find them in advance and find people who share your passions and problems so that they can better understand what it is you're trying to create for the hackathon itself. And of course, you can also find people with complementary skill sets. So maybe you're really good at programming, but maybe you're not so good at UX and design. And all of these things need to work together to make a really good, robust system that could win you the hackathon, of course. So let me walk through a case study here. Some of you may have seen an example I put together where I made a clothing size estimator. And I want to show you how I came up with this idea and what led me to this thought process. So going through these questions again, what was on my mind regularly? Well, I needed to buy some new clothes, but I don't have the time to go to all the stores. And also in the current situations where we're all stuck at home, I couldn't go to the stores because they were closed and only available online. Now, what problems existed in these areas? Well, a lot of people, when they're shopping online, don't know the size of the clothing that they want to buy. And of course, for different brands, they have different sizing measurements as to what is a small, medium, and large piece of clothing. So added to this, not everyone enjoys trying on clothes in the first place. So there's many reasons why this was a problem for people. Now, what was new in the tech stacks I was considering? Well, at the point in time I started this, I was fairly new to TensorFlow.js, and I realized there was a new model that came out for body segmentation. And I figured with this, I could repurpose that to actually do measurements of the human body in real time in the web browser. And who else was interested? Well, after talking to a lot of people, it seemed that a lot of people had the same problem as me, and they'd be good candidates to test out this prototype I wanted to make. So here's the result. After 2 days of hacking, I managed to make this prototype using TensorFlow.js BodyPix model to measure myself in under 15 seconds, right at the point of checkout. So now I can just stand in front of the web camera, turn once to the side, and get my chest, waist, and inner leg measurements, which the website can then automatically use to tell me if I'm a small, medium, or large for a t-shirt or something like this. And of course, it was made in just 2 days. Now, why would you want to consider JavaScript for hackathons? That's a great question. And the reason I propose JavaScript here is that it's really great for prototyping. First of all, there's a huge community. Over 67% of professional developers, according to the Stack Overflow survey of 2020, use JavaScript in production. And that means there's plenty of support if you need it. No matter if you're beginner, intermediate, or advanced, someone is always there to be by your side. Second point, graphics and graphical user interfaces are far easier to create in JavaScript than other languages. We've got really rich libraries for 2D and 3D graphics, charting, and data visualization, and much, much more. In fact, from the very beginning, the web has all been about the presentation of information. So the libraries are very battle-hardened for this kind of stuff. The third point is higher shareability. Anyone in the world can click a link and view a web page to try your prototype. And if you want your prototype to go viral and get a lot of people's attention, then the web is a great way to deploy that. Now, looking at the sensors that you can use and emerging technologies, in JavaScript, you can have access to the camera, microphone, accelerometer, GPS, and many, many more sensors that are coming out all the time. And with emerging web technologies like WebXR for mixed reality, WebVR for virtual reality, and even things like WebRTC for real-time communication, you can combine all these technologies together to make some really impressive prototypes, which we'll see later in this presentation. And then the final point here is it allows you to reuse your code across stacks. JavaScript runs pretty much everywhere, which is really, really useful. And TensorFlow.js is essentially a machine learning library written in JavaScript. And of course, that means several advantages. The first one is lower latency. Secondly, user privacy. And of course, very easy deployment. And here you can see all the different areas you can deploy with for TensorFlow.js. On the left-hand side there are all the common web browsers you know and love. And of course, we can also run on the server side with Node.js. And then for mobile native applications, we can use React Native, and desktop native applications, we can use Electron. And even better, we can execute on the Raspberry Pi via Node. So we can even execute on Internet of Things devices for hardware-based projects. And JavaScript is one of the only languages that can run across all of these devices without any additional plugins and so on and so forth. So this is very, very powerful just for this purpose alone. And TensorFlow.js allows you to run, retrain via transfer learning, or write your own machine learning models completely from scratch if you choose to do so, just like you might be doing already in Python, but in JavaScript. And this allows you to make up pretty much anything you could possibly want, from augmented reality, sound recognition, sentiment analysis, conversational AI, and much, much more. In fact, let's look at some of the inspiration as to what the TensorFlow.js community have been making so far this year. And these are just a few examples that I've picked, but there's many, many more, which I'll show you how to find at the end of the show. So the first up is Face Mask. This is actually made by one of the members of the community, and it allows you to wear a mask in real time. You can see here, he can drag any image from the left into the web browser. It can then find the face in that image and apply it in 3D to the face of the webcam in real time, all in the web browser. And because this is running in the web browser, the privacy of the person is preserved. None of the imagery from the webcam is being sent to a server for analysis. It's all happening live in the browser and staying completely on the client side. What about understanding human language? Here we can see how we've used a model called BERT Q&A to understand a human text. You can actually ask a question, and we can now scroll to the part of the website that actually answers the question. So this can work on any long form piece of text and is super, super powerful. It's much more powerful than just a Control F for find, where you need to know the word in advance. Here you can ask a genuine question and it understands you well enough to then find that answer in the text. What about this one from the community for depth estimation? Here, someone's converted a Python model into JavaScript to run in the browser to do depth estimation on images. You can upload an image in this case, and it can then estimate the depth of all the pixels in that image, allowing you to reconstruct things in 3 dimensions, like this sofa here, which you can see on the right-hand side. Now, this runs a little bit slow right now, but even so, this could still lead to some very interesting use cases for a hackathon. Maybe a user could upload an image of something in their room, and you could extract the depth information of this and convert it into a 3D model to use in a game engine in the browser or export it somewhere else. All of this could be possible with just a few clicks if you really wanted to. And how about Sounds of India? Here, a Google team allowed you to turn your voice into musical instruments while singing the national anthem of India. And basically, it would convert your voice into classical Indian musical instruments. And this had over 100 million uses worldwide, I believe. So it's really popular because it was shareable. And then, of course, Pose Animator, which was made by a fellow Googler over in China, allows you to animate any SVG character using your body. Now, this is really cool because it uses multiple TensorFlow.js models in the same web browser. Here, she's using the face mesh and our PoseNet model to understand her face expressions and her body pose all in real time, which you can then use to drive any SVG character she's drawn in Illustrator, for example, and then exported and uploaded to the web. And you can see how beautiful this comes to life. And this could be very, very useful for many things and many other industries too. If you wanted to do motion capture for animation or something like this, this is a very useful tool and could help many, many people. Or what about gesture? We've seen a lot of people from our community explore human-computer interaction. And this guy is using our hand pose model that allows us to recognize various key points in 3D of a hand on a human. And you can see here, he's made this beautiful illustration showing what his hand is doing in real time. And with his understanding of this, he can now control elements of the web page using his hands, such as swiping left to swipe through a slide, or to turn the volume up and down, or whatever he wants to do. And this is an ongoing piece of research, but I'm excited to see where it might go. And there's also artistic and creative combinations too. This lady from the community has combined Python and TensorFlow.js together. There's 2 models in action here. On the Python side, she used a generative network to generate new faces of the Mona Lisa, as you can see on the left-hand side. And she then combined that with a TensorFlow.js model running in the browser called Face Mesh that allows her to detect where her face is. And then as she moves across the webcam, she can change which picture to display in real time in the browser. And this means it can run anywhere. So this is a nice combination of models that she used to get this to work, and shows that you can actually combine things from Python and JavaScript together to get very powerful effects like this. Or how about using existing hardware? Here, a guy from the community is literally taking accelerometer data from his mobile phone and using TensorFlow.js to categorize the flips he's doing in real time. And you can see the different red markers as to what type of flip he's doing. So imagine you use this on a skateboard or something like this. Maybe you could learn the tricks of skateboarders to tell them when they've done a certain trick and to record that. And maybe they can challenge their friends in the same area to do the same trick or a better one and outdo each other. It could be fun to do something like this too. And you can go even further. You can actually combine TensorFlow.js with hardware too. This guy has made some custom hardware that's combined with TensorFlow.js to track this tennis player in real time to get the perfect shot all the time. This is especially important for fast-moving sports where people find it hard to track the person as they're moving. And here's a few more examples that I've created myself. Here, I can make myself invisible in real time. Some of you may have seen this on Twitter already, but notice as I get onto the bed, I can remove myself from the frame in real time, but the bed actually still deforms. So this is more powerful than a cheap trick where you're just replacing with the image background. The laptop and the bed update in real time, even though I'm removed. And this is super powerful and is a lot of fun to try. We can go into superpowers as well by shooting lasers from our eyes and mouths, as you can see here from another member of our community. This uses WebGL shaders in the browser combined with our face mesh model to understand where the eyes and mouth are in 3D in order to do this. And it runs super smooth. And of course, this could be used for many creative things in the industry, such as the movie industry, where you might want to create an experience for fans of Iron Man so they can actually become him and live the dream, so to speak. I also explored teleportation with TensorFlow.js. Here, you can see how I segment myself from the bedroom in step 2. I can transmit that segmentation over the internet, and then using a separate phone, I can place myself in a different physical location, and then I can talk to people remotely as if I really was there. And I made this once again because of a problem I had in my life. I am from England originally, and I'm currently based in San Francisco, and I found it hard to communicate with friends and family back home when I couldn't go to see them. So using a technology like this allows me to be more physically present, even though I can't be physically there, and it gives the illusion that we're actually talking to each other in a more meaningful way. And it's much better than having being stuck in a rectangle on a Zoom call or something like this. So maybe in the future, this is how I'll present to you, and you'll see me in your living room as I talk. And another guy from the community did something similar by scanning magazines to take the fashion models out of the magazines and bring them into your room using this really cool particle effect. And what's really awesome here is that this is actually running on a 2 or 3 year old Android device, but it's still able to achieve these great particle effects in real time, along with the machine learning. And this is all running in the web browser, don't forget, using JavaScript. So we've seen some great inspiration there. But how were all these prototypes made? Well, a lot of them actually used our pre-trained models from TensorFlow.js, and these are simply really easy to use JavaScript classes for many common use cases. And you don't even need to be a machine learning expert to use them. You just need to be familiar with JavaScript. And we've got many of these models that are available for you to use in just a few lines of code, just like any API you would typically use. Things like object detection, body segmentation to understand where the human body is in a given image, pose estimation to understand the pose of that body. We've got things like face mesh and hand pose to understand the key points of the face and the hands respectively, and our BERT Q&A model to understand natural language processing. And there's many others you can check out on our website, tensorflow.org/js/models, as you see on the slides. So let's go into some of these in detail just to see them in action and to see what they're capable of doing. Now, first up is object recognition. This is using a model called Coco SSD behind the scenes, and don't worry about the name, that's just a fancy name for the model architecture that it's using. What's happening here is that it's been pre-trained on 90 common object classes, things like cats, dogs, mobile phones, beds, couches, things you might have seen in everyday life. And it's capable of recognizing those objects in a given image, like you can see on the right-hand side with these dogs. And even better, it can tell you the bounding box of where that object is. So then you can draw physically where the object is in the image, and you can also count how many of them that there are, which is very, very useful. So let's go ahead and see this in action with a live demo and show it working in the browser live. So if I bring over my web browser here, you can see a glitch example I've just created for this. And if I click on any one of these images, you can see I can get real-time classifications coming back. You can see that the dog is quite close to this bowl of treats. So you can imagine very quickly how you can make a smart webcam like a Nest Cam to get even more powerful than a Nest Cam, in fact, because we can now know that the dog is close to the bowl of treats, and maybe you want to send yourself an alert that your dog is being naughty, or something along those lines. But we could go even further than this, of course. We can click on Enable Webcam, and now I'm able to do real-time classification as I'm speaking to you here today, live, and you can see it's recognizing me as a person in my bedroom. And remember, this is all happening live in the web browser on the client side in JavaScript. None of this imagery is being sent to a web server for classification, so my privacy is preserved, and it's super fast because I'm not having to send the video to a remote server that could be very far away. So bear that in mind when you're using TensorFlow.js as well. It can give you these benefits too. So back to the slides, 1 second. Next up, we've got body segmentation. This allows you to distinguish 24 body areas across multiple bodies, all in real time, as you can see on the slide. And on the right-hand side, you can see how we can segment the body into different parts as well. Arms, legs, torso, head, so on and so forth. And even better, we can see the pose estimation, those blue lines of where we believe their skeleton to be, which is very useful to do things like yoga workouts or maybe rep counters for fitness. And we're also seeing the community do these kinds of projects as well. What about text toxicity detection? This essentially allows you to pass us a sentence and we'll tell you if we think it's toxic or not. And we can tell you what type of toxicity it is, as you can see from the right-hand side in the table. So you can imagine how you might turn this into a Chrome extension. And yes, TensorFlow.js can run in Chrome extensions too. So you can scan the comments of, say, YouTube or a blog post and automatically hide the toxic ones, so you can browse the internet in a safer way. Or maybe that would be good for children so they don't see offensive messages. Just one idea that you could possibly make using this technology. And there's many, many more if you get creative with it. How about face mesh? Just 3 megabytes in size, and it can recognize 468 landmarks on the human face, as you can see on the left-hand side here. Now, actually, this is an old GIF. We've got a new model that just came out that also does iris detection, so we can understand if your eye is open or closed, and also where your iris is actually located, which is very useful for various things. And we're starting to see business use cases for this kind of model too. You can see here on the right-hand side, Modiface, who's part of the L'Oreal group, have used this for AR makeup try-on. And the thing to note here, on the right-hand side, is that this lady is not wearing any lipstick. This is actually rendered in real time in the web browser using TensorFlow.js combined with WebGL shaders and our face mesh model that you see here. Now, the lady on the right can simply swap through different color swatches and try them on before she's even gone to the shop. And she can now buy it in confidence, knowing what it's going to look like on her face. How about speech commands? We can also do audio detection for short form audio. And this is hard to demo right now, but you can trust me here that all these things that are being highlighted are things that I was saying at the time. I was speaking out these numbers and these words, and as I said them, it could highlight the correct one for me. So you can imagine how you can make a custom version of this to recognize custom sounds, maybe to do whatever you wish. Maybe a smart media player that's controlled by your voice or something else. It's really up to you, and it's only limited by the creativity. How about hand pose? This one we saw in some of our previous demos, and it can recognize 21 three-dimensional hand key points on each hand from a single image. And of course, a video is just a bunch of images. So you call it many times per second, and you can get real-time performance, as you see here on the GIF on the right-hand side. And then finally, we've got a question and answer model as well, which we saw in one of the previous demos too. And as mentioned, this allows you to search long-form text with a question, and it will scan it to try and find an answer that's most relevant to the question being asked. And this works on any piece of text. You don't need to have trained on the text in advance. It completely works on pretty much everything, which is really cool. It was actually trained on, I believe, Wikipedia entries. So text that is in that kind of format works better, but have it go and use it on your own text and see what you might want to use it for. So I now want to go into a bit of the behind the scenes of how TensorFlow.js is structured and some of the superpowers and performance benefits you can get by using this in the browser or on the server side. So TensorFlow.js has two APIs. It's got a high-level API called the layers API, and that's very similar to Keras if you're familiar with Python. Now, we've also got a lower-level ops API. That's the more mathematical layer that allows you to do things like linear algebra and so on and so forth if you wish to go down to those levels. But you don't have to if you don't want to, of course. That's only if you're going to be making your own custom models from a blank canvas. So you can see how these come together. We've got our pre-made models that we just spoke about on the previous slides at the very top, and they're built upon our layers API. That layers API talks to the lower level cores API, and then that understands how to execute in different environments, such as the client side. And by client side, of course, we mean the web browser in this case. Now, this environment then understands how to talk to different backends, and you can see here the client side of the web browser supports 3 different backends at present. The first one is the CPU, and this is always available. The second one is WebGL, and this allows us to execute on the graphics card on the computer. And then the third one is WASM, or WebAssembly, and essentially this allows us to get better performance on the CPU by utilizing lower level instructions. Now, the same is true on the server side as well, and in the server side we can execute in Node.js instead. And our Node.js implementation has the same TF-CPU and TF-GPU bindings as the Python version of TensorFlow. And these basically talk to the same C++ API behind the scenes, so they both get the same AVX and CUDA acceleration, if you're familiar with that over in Python land. In fact, the performance is exactly the same pretty much. Now, if you are working in Python and you want to continue to do so, but then scale it with the reach and scale of the web, you can actually take Keras and TensorFlow saved models and load them via the layers and core API respectively without any conversion. But then, of course, this might make it easier for you to work with someone who's using Node.js to bring that implementation to the web, to then allow anyone to use it. So when you're working with other people in a hackathon, this could be really useful. If one of you is using Python and one of you is using Node, you can now meet in the middle and use the work produced by another person. Or even better, if you want to convert a TensorFlow saved model from Python to run completely in the web browser on the client side and not in Node.js, then we've got a command line converter that can help you take the saved model format and convert it to the model.json format that you need to run in the web browser. And you can use the command line converter tool to do that. So there's also 5 client-side superpowers that you can get by running TensorFlow.js on the client side. And these are hard or impossible to achieve on the server side. The first one, of course, is privacy. Now, if you're running on the client side, that means that there's no data going to the server because we're able to do all of that inference on the client side. And this is particularly important for certain industries like medical or legal, or in certain countries where there's very strict laws and regulations about sending things to third parties. Or the second point here, lower latency. If we're not having to send data to a server, we can cut out the latency involved, which on a mobile device in the middle of a field could be a couple of 100 milliseconds before you get a response from the server. And that means real time would not be possible unless you do it on device. And TensorFlow.js allows you to do that. Now, the third point is lower cost. If you're not having to hire expensive servers with big GPUs, lots of RAM, and very beefy processors, then of course you can make a significant cost saving both in your hackathon and, of course, if it turns into a real service that you offer for people afterwards. And the fourth point is interactivity. We spoke about this earlier, but JavaScript from day one has been all about the display and presentation of information on the World Wide Web. So there's very rich libraries to do interaction. And then the fifth point is the reach and scale. Anyone can click a link and go to a web page. Not everyone can take a backend project and recreate the environment exactly and then read your README files of GitHub and install any dependencies. That's a lot harder and a higher barrier entry to overcome, which means less people will use your prototype if it's in that format. So by having the reach and scale of the web, anyone can try it out instantaneously without any need to install anything else other than a web browser. Now, on the server side, if you're executing TensorFlow.js in Node.js, there's also some benefits there. So as I mentioned, it allows you to execute a saved model without conversion, so you can work with Python developers who might be doing the machine learning in Python. And it also allows you to run larger models than you can do on the client side, Obviously, if you have a model that's gigabytes in size, you don't want to send that down to the client side because that's going to take far too long. It also allows you to code in just one language. If you're already using JavaScript, and of course, 67% of developers actually use JavaScript, then it allows you to work in a more consistent way and keep your code in one language that can improve readability and maintenance. And then the fourth point is performance. It's got the same C bindings as the original TensorFlow in Python, but it can actually be faster than Python sometimes because of a just-in-time compiler boost if you convert the pre- and post-processing layers into Node.js. So I'm going to end here with some resources to get started. If there's one slide that you should go and look at after this show, if you want to kind of find out more, let it be this slide here. The first link is a link to our website, and I encourage you to read through that to get an idea and feel for what's possible. Check out our models on the link shown there. And then we're an open source project, so all of our code is also available on GitHub for free. And we have a Google group for more advanced technical questions, which is shown here. And we've got some boilerplate code on CodePen and Glitch, which you can use to get started very fast from a working point. So in fact, the demo I showed you earlier for the webcam classification is available on glitch.com. You can fork that and you can have a starting working point with webcam access and all this kind of stuff, which you can then use and turn into something very, very creative. If you want to go deeper, there's also a book called Deep Learning with JavaScript that was written by people on my team. And that's a very robust book. And the only prerequisite is to understand JavaScript. So with that, I invite you all to come join the Made with TensorFlow.js community. We've got many, many projects coming out every single week around the world. And there's a lot coming from India, actually, which I'm pleased to see. And if you search Made with TF.js on Twitter or LinkedIn, you'll find a whole bunch of extra projects which are coming out all the time, which are far more than I can show you in today's presentation. So do check that out for inspiration too. And of course, if you make anything, use the hashtag so we can find it. So that leads me to my last question here is, what will you make with TensorFlow.js? I want to end you with this final piece of inspiration. This is a guy from Tokyo, Japan, who's actually a dancer by day, but he's used TensorFlow.js BodyPix model to make this really cool hip hop video. And my point for showing you this is that machine learning really now is for everybody. It's not just for academics and engineers, but now we're starting to see musicians, artists, creatives taking their first steps by using TensorFlow.js in the browser to make these amazing projects. And I look forward to seeing what you create as well. And of course, on that note, if you are hacking with TensorFlow.js with this hackCBS hackathon this year, you have a chance to win a Pixel for a smartphone for everyone on your team. So please do use TensorFlow.js. And if you do, use that hashtag made with TFJS so we can find your work on social. And of course, let the hackCBS organizers know so they can get in touch with us so we can see your projects too. And you might be wondering what kind of categories might be interesting for hacking with here. So I wanted to go through a few thought starters. So if you're new to machine learning, you might choose to use our pre-made models. Maybe here, you should try and make something that we've not seen before that uses one or more of our existing models that you saw today, and combine those models with emerging web technologies to really push the boundaries of what's possible in the browser. Maybe you can solve an idea or a problem that you have, just like some of the demos you saw today. And of course, you can combine this with any third-party libraries you wish. Now, for this to be judged, we need to see a working demo on the live web page for us to view and try. The second way you might want to use TensorFlow.js is to try and convert a TensorFlow Python model and make it available to the JavaScript community with a live demo. So the key point here is that this model should not have existed before, and ideally, this is something useful that many people can then reuse. And again, we want to see a working demo of that if you choose to go down route number 2 here. And route number 3, if you choose to, if you're more braver and maybe more experienced with machine learning, is to make a completely custom model that does not yet exist. And maybe you can use it to solve a problem or use it creatively in some way. And ideally, whatever you produce can be used by more than just yourself. Maybe other people could make use of this model too. And again, we'd love to see a working demo of this in action for us to view and try. So with that, if you've got any questions, I'm available on Twitter and LinkedIn. I encourage you all to add me over there. On Twitter, it's Jason_Mays. And on LinkedIn, I'm Creative Tech. And the only thing I would like to point out extra is in December the 11th, we have a Made with TFJS show and tell, which is where we get people from the community to come and speak live about their projects, just like the things you saw today. And we've got 6 new projects to show you that are really awesome. So do come join us on December the 11th for that live show as well. And with that, thank you very much for listening. And I'll take any questions now if people want to. And if not, I'll see you on Twitter and LinkedIn. Thank you very much. Okay. I'm checking the YouTube live chat. If anyone's got any questions there for now, feel free to repeat your question, as I may not have seen it if it's scrolled away already. So if you have any questions now, feel free to write them in the YouTube chat, and I will be checking that right now as I'm speaking. People are asking, is there a deck of the presentation? I can look into that for you. I don't have it to hand right now, but I can generate one, and maybe the organizers can send around the PDF for you if that's possible. How does TensorFlow manage low latency? So this is very much down to the very experienced model creators that we have here at Google and in the community. And essentially, they are minimizing the number of operations and the depth of the model without sacrificing the accuracy too much. So they're learning to optimize the models and prune the models to be very powerful and still run in the browser. Of course, we can also leverage the GPU in the browser using WebGL, and that's another way we can make things go much faster. And also WebAssembly also allows us to make smaller models go even faster too. So for WebAssembly, we've actually seen like a 10 times performance boost by using the new lower level instructions that have just come out, like SIMD and this kind of stuff. So yeah, do try those environments out in TensorFlow.js if you're having performance issues. Any tips on converting a PyTorch model to TensorFlow? Unfortunately, it's not an easy path to do that. I believe you'll have to go through some intermediate format to get it to the TensorFlow format. And then from TensorFlow, you can then go to TensorFlow.js. So it's a bit of a long way around. I've forgotten the name of the intermediate format right now, but there's something that you can convert PyTorch to. I've forgotten the name of it right now, but there is a format you can convert that to, which then can be digested and converted into TensorFlow Python. Cool. Yeah, I think that's all the questions. Oh, there's one more coming up. How can we use the pre-made models? So if you go to tensorflow.org/js/models, you can see all the models that we have available. And if you click on any one of them, it will take you through to our GitHub page that has a nice README file with working examples of the code you need to write to get them to work. And it's literally a few lines of JavaScript. If you know JavaScript, you'll find it super easy. It's probably easier than most APIs you've ever used. And there's also some examples on glitch.com and codepen.io. If you search for TensorFlow.js on there, you'll find me or TensorFlow.js page. And we've got some examples there on how to use the models as well. And once you know how to use one, it's pretty much the same for the others. You're just calling a different function name. Is it possible to use on single pen on CodePen? I don't know what you mean by that, but yes, it can run on CodePen and it can run on Glitch. Yes, you can. It runs on a single pen. I've got many demos on there already, which are like this. Can TensorFlow be deployed in container software? Yes, if you're using things like Kubernetes and that kind of stuff, you can make environments that you can then deploy in a container. People do that in the cloud, and that's how they scale over cloud-based machine learning. Can a web developer who doesn't know any ML use TensorFlow.js? Yes, you can. As long as you know JavaScript, you can use our pre-made models. And our pre-made models are just like using JavaScript and are very easy to use. You don't need to understand machine learning to be able to use those pre-made models. So do check them out. Don't be scared about those. They're really easy. And you can get started in minutes if you know JavaScript. If you want to make a custom model from scratch, then you'll need to start reading some books and go a little bit deeper. But all the demos almost all of the demos you saw today use some of our pre-made models to make them come to life. And that means every single one of those developers did not have a background in machine learning. They're just JavaScript developers just like you. Cool. Any other questions? And we'll wrap up. If not, I'll give you 10 more seconds to ask a question if you have any.
Indeed.
Sorry, I think there's one more. I'll just quickly answer that, and then I'll hand back to you. Can I make something for the hackathon in TensorFlow? Yeah, oh, sorry, yes. Yes, you can. It doesn't matter if you're a noob or not. Check out the pre-made models and check the documentation and just read it. And I guarantee you'll be able to understand it if you know the basics of JavaScript. And if not, reach out to me on Twitter and LinkedIn. I can show you. It's not hard. Cool. I'll hand back to the presenters. Thank you very much for having me today. Cheers.
Indeed, a very insightful session. I hope people here got inspired a lot from this session, and surely they will implement TensorFlow in their project and going to make some wonderful projects. So we are very thankful to you, Jason, for sharing your knowledge with our participants. We are very delighted to have you here at HackCBS, and we hope that you will also join us in the further editions of HackCBS.
Certainly, thank you.
So if anybody is left with any questions or queries, Jason is also available in our Discord server to answer your queries. We have created a separate channel with TensorFlow at HackCBS. You can ask your questions to Jason in that channel as well. So awesome. Thanks, Jason, once again. It was a wonderful session, and it was amazing hosting you today. Thank you so much.
Thank you very much. Bye-bye.
Bye. So I would like to thank your very patient audience too. Just a quick notification, we are having our next workshop at 5 p.m. today itself on placement preparations for product-based companies by Sandeep Jain. So do set up your alarms for that workshop too, and hope to see you all there. Also, don't forget to fill the feedback form. It is there in the chat to avail your certificates for this session. Thank you so much.